Hello students, in this video I am going to explain you magnetic field of a toroid. Let us start the video. What is a solenoid? Solenoid is a long cylindrical helix which is made by winding closely large number of turns of insulated copper wire, and when current is passed through the wire, magnetic field is produced. Now when this solenoid is bent in the form of a circle, it acts like an endless solenoid or simply a toroid. That is, it is a hollow circular ring on which a large number of turns of laminated conducting wire is closely wounded. Here I have considered the current flowing through the toroid is I. This is the representation of toroid, that is a solenoid bent in the form of a circle, and let n be the number of turns per unit length. Now this figure is the sectional view of the toroid. If you look carefully, the current is from top to bottom. So the direction of the current is from top to bottom. And if we have grasped this solenoid in our right hand, the fingers encircled will represent the direction of the current, and the direction of the thumb pointing will represent the direction of the magnetic field as shown here. Now to understand the magnetic field, we will consider 3 points, that is point P, the interior of the solenoid, point Q, exterior of the solenoid, and point S within the solenoid. You see here the current pointing out is represented by dots and the current pointing in is represented by cross. The number of crosses here will be exactly equal to the number of dots here, because the same wire is pointing out and pointing in, and the representation of the current is by dots and by crosses. So for this, as we have considered 3 points, we draw circular Amperian loops of radius R1, R2 and R3 passing through these points P, S and Q. And by symmetry, we are aware that the magnetic field on these Amperian loops will be same throughout. Now consider an elemental length dl, and we find that the magnetic field is constant in magnitude on this circle by symmetry, and its direction will be same as the direction of the length element dl. See the loops here. This is loop 1 passing through point P, this is loop 2 passing through point S, and this is loop 3 passing through point Q. Let the magnetic field through loop 1, 2 and 3 be represented by B1, B2 and B3. Let us see and calculate the magnetic field due to loop 1. We are aware from the Ampere circuitor law that line integral of magnetic field dot dl will be equal to mu naught into current enclosed by that loop. Let us apply it. Line integral of B naught dl can be represented as B1 dl cos 0, as the direction of both magnetic field and the length element is same, so the direction or the angle between them is 0. It will come out to be B1 into line integral of dl. dl means the entire loop 1, that is the circumference of this loop. So it will come out to be 2 pi r1 into B1. And the current enclosed by the loop 1 is 0. See how? As this loop 1 is interior of the toroid, there are no symbols for dots and crosses here, that is no current is passing through this loop. So the current enclosed is 0. And if the right hand side of the Ampere's circuital law is 0, this R cannot be 0. So what we are left with, that the magnetic field will come out to be 0, like this. So from this we have concluded that the magnetic field in the interior of the toroid is 0. Now let us see for the magnetic field at an exterior point, that is at point Q. Now see carefully, the magnitude of the current entering and leaving the Amperian loop is same. So they will cancel each other. See again from the figure, this point Q and the loop 3 consist of equal number of dots and crosses. So the current pointing in and the current coming out will be exactly same, hence they will cancel each other. So the current enclosed in loop 3 is 0. Then again by Ampere's circuital law, line integral of B dot dl is equal to mu naught into current enclosed by loop 3, which is 0, and the left hand side becomes B3 dl cos 0, because the direction is same of magnetic field and the line element. So it will come out to be B3 into 2 pi R3. So equating the two, we have obtained this equation. Again the right hand side is 0, and from the left hand side this radius cannot be 0, so only term which can be 0 is the magnetic field, that is B3 is 0. Now see for the loop 2, line integral of B2 dot dl is equal to mu naught into current enclosed in loop 2, that is by Ampere's circuital law. This line element can be written as B2 into 2 pi R2 exactly in the same way as we have done for the loop 1 and loop 3. The right hand side, in which we are talking about the current enclosed in loop 2, can be calculated by number of turns in this loop and the current in each turn, because in this loop the current is passing once through this loop, so it will be 2 pi R2 n into I. Putting back in the Ampere's circuital law equation, so we have obtained B2 is equal to mu naught Ni, or we conclude that the entire magnetic field is concentrated within the interior of the toroid, and on the exterior points there is no magnetic field. Thanks for watching. Please like, share and subscribe.